The electrical stimulator used for nerve conduction studies has two pins, cathode and anode. They are also called the negative and positive pins. In some stimulator probes, they are indicated by black color for cathode and red for anode. On modern systems, the cathode is indicated by an illuminated LED. The cathode is placed over the nerve for stimulation. The anode position may be varied and can be off the nerve to reduce the stimulus artifact. The anode provides a path to complete the stimulator circuit. The stimulator can be operated in two modes, constant voltage or constant current. In the constant current mode, the user-specified current passes through the stimulator and body tissue. The instrument will generate enough voltage across the anode and cathode to generate the necessary current. The voltage will vary depending upon the impedance at the stimulation site. Most electromyographs can deliver up to 400 volts. In this example, the desired current is 10 milliamperes. Let's say the impedance is 10 kiloohms. Hence, the stimulator will generate 100 volts across the anode and cathode to deliver the necessary current. If the impedance is 20 kiloohms, the system will apply 200 volts to deliver the desired current. Hence, there should be no problem in stimulating with 10 milliamp intensity in these situations. But if the impedance is very high, say 100 kiloohms, the required voltage will be 1000 volts. The system cannot generate such a voltage. Using a maximum of 400 volts, only 4 milliampere current will be produced. In this instance, the system will deliver less current than the setting dialed by the user. This failure is often indicated by using different colors in stimulus intensity display on the system. In the constant voltage mode, the instrument will apply the user-specified voltage across the anode and cathode. The current passing through the body tissue will be inversely proportional to the impedance at the stimulation site. If the impedance is low, such as 10 or 20 kiloohms, sufficient current may pass to excite the nerve. In this example, if the impedance is 100 kiloohm, only 2 milliampere current will pass even when the maximum voltage is applied by the stimulator. This may produce submaximal stimulation of the nerve, and one may misinterpret the low amplitude response as abnormal. The stimulation may be inadequate in constant voltage or constant current mode due to high impedance at stimulation site. It is the responsibility of the operator to use proper techniques of stimulation and to recognize when stimulation is inadequate for technical reasons. To deliver the necessary stimulus, it is extremely important to make sure that the anode and cathode make good electrical contact with the skin. It is a good practice to clean the skin surface at the stimulation site using the alcohol pad, just as it is done for the recording electrode sites. Use of electrolytic gel will also reduce the impedance under anode and cathode. Avoid excessive use of gel that can spread on the skin surface and create a short circuit between the anode and cathode. In this situation, the current will pass over the skin rather than passing through the body tissue. This will also result in inadequate stimulation. The shape of the stimulus pulse is usually monophasic. Modern systems also offer the so-called biphasic stimulation. It consists of two pulses of opposite polarity applied back to back. This can be helpful to reduce stimulation artifact, as discussed in a companion section.